In this final example, I'm going to show how we use a continuous director to constantly read values from an instrument. In this case, it's a digital multimeter. I have the example here and I'll run it. You are familiar from the other examples pretty much what's going on, and I can select my digital multimeter here. It's going to get the ID and then it's going to run a 2Y resistance reading on the multimeter, which is connected up to a trimmer. So if I start that, you can see it's now generating this waveform. It's quite jagged, but that's actually because the value is not changing significantly. Okay, you can see that if I adjust the trimmer, you can see how that impacts the waveform. So I'm adjusting the trimmer now. Up and down. And so you get the idea. It's just constantly reading values from the multimeter. I can pause this, in which case it stopped getting any readings whatsoever, and resume it when I'm ready. Now that little jump you saw was really because the x-axis is based on time, and obviously the elapsed time was a few seconds whilst it was paused. That's it really. It's nothing particularly complicated. It's using a measure command, and we're using the function that we select here, and there is a choice with 4-wire, diode, capacitance. So there's a choice, a function we can use here. And those are, and the framework creates the command with these functions and parameters automatically. So in this case here, we're using a timestamp as a parameter, so that as well as getting the reading, the value in ohms from the DMM, we're also retrieving the timestamp as well. And this just allows me then to map it onto this waveform graph. So let's stop that. Now you see this in the block diagram. It won't look any different to the other examples that you've seen. In action 1, which is called when we press the start button, you can see that here, we're building the waveform executables and passing it in on the run interaction. We're not going to be injecting commands, and this time I've got a wait time of 100 milliseconds between the command directors. The result that comes back on the notifier is handled through here, so we get the instrument ID if it can find if it matches the ID on the read command. Otherwise, it's a waveform measurement, and we pass that waveform measurement out of there, out of the parameters actually. So our read command is downcast into a scoping measure command. We get hold of the parameters because I've asked for the reading along with the timestamp to come through as parameters. The first value is the actual reading, and the second value is the timestamp, and we're using that to create a waveform entry and adding it onto, well, that's just the parameter, but adding it onto the indicator here on the front panel. So action 1, we're building the waveform. We're getting the ID, that's the ID command, you've seen that before. We're mapping to the right driver. In this case it's going to, because we've selected a DMM 6500 by name, it's going to find a driver, an instrument that matches that name. Create the buffer. So in this case I'm actually using a buffer to manage the readings on the DMM, and you can see I'm using the user defined write, so I can just enter the command that I need on there. My buffer is 100,000, 10,000 entries. Create that as a command, add the driver to it, and this is a command director, so it's a single shot command director. Okay, you should be familiar with these now. and the setup wave measurement. What you'll see here is we're adding these in order. So the first one is the get ID, then we've got the creating the buffer, and the next one will be set up the wave measurement command. And we're interested in two IDs coming through. One is for the instrument identity, and the other is for waveform measurements. So our Scuppy measure command is what we're going to run. We add the driver to it. We configure that measure command with the name of a buffer, and these are parameters that I'm interested in. So I use a helper function to build the parameters. Those are value name value pairs, and add the parameters onto the command. And the ID is coming on, and this add command is coming on to a continuous director. So the continuous director just runs forever until we press the stop button. The framework tells it to stop. Now if we look at how this might get created as a command, we've got the measure class here. The base command will look like this. We've got a formatted function that returns if I look, so based on the selection, a sort of more English sounding selection, such as 2-wire resistance, it actually converts it into the Scuppy value here. Now this isn't ideal, and I will come back and sort this out in a future iteration. I've just sort of run out of time really in terms of the challenge here. And 2-wire resistance is just the function is :res, and we're just mapping that out onto there. And so our command then, it starts off as :measure. We're adding in the function :res and a question mark, and we're also getting the buffer. Remember, that was my buffer, and it adds that in with quotes around them, and passes that out, and that then is the base command. And then the final part of building the command is let me. Oh, it is. So building the command, we get the base command, which we've just gone through, and then we get the parameters, and for each parameter, for its name, we add that onto the end of the command with a comma separator if there's more than one of them. If it is the last parameter, we don't get the comma. It's not added in, and we put a terminator on as well. So when you're creating your own commands, you don't actually need that terminator in the command string, because the framework will actually put it on for you. So that builds up the command, and you've seen writing, reading in some detail on the first example. So this one's not at all complicated. It's not that much more complex than the instrument identification example, actually. But it just shows you another view of interacting with instruments, where you're running a long-running process against perhaps a PCB you've created. You're testing it. You can step through voltages, measure capacitance, and so on and so forth through this type of process, long-running process.